Alright, let's look at an example of a rate of change problem where we're going to find the average rate of change and the instantaneous rate of change. Let's say that I have a function f of x equals x cubed, and I have 2 points. I have x sub 0 equals 1 and x sub 1 equals 2. So now if I'm finding the average rate of change of this function, I know that my formula is going to be f of x sub 1 minus f of x sub 0 all over x sub 1 minus x sub 0. Plugging in these values, I know that x sub 1 is equal to 2, so plugging 2 into my function gets me 2 cubed, minus x sub 0 is 1, plugging a 1 into my function gets me 1 cubed, and this will all be over 2 minus 1. Alright, so evaluating this, 2 cubed is equal to 8, minus 1 cubed is equal to 1, over 2 minus 1 is equal to 1. So my average rate of change between the points x sub 0 and x sub 1 is equal to 7. Alright, let's look at the instantaneous rate of change at the point x sub 0. So I know that my instantaneous rate of change formula is the limit as h goes to 0 of f of x sub 0 plus h minus f of x sub 0 all over h. Alright, so evaluating these functions, I know that x sub 0 is equal to 1, so I'm plugging a 1 plus h into my function. And that's going to get me a 1 plus h cubed. And then I'm plugging a 1 into my function, so I'm subtracting a 1 cubed. And that's all over h. Alright, so let's expand out my numerator. I know that 1 plus h cubed is equal to h cubed plus 3h squared plus 3h plus 1. And then I'm subtracting 1 cubed, which is really just subtracting 1. And that's all over h. Now I notice in the numerator, I'm adding 1 and subtracting 1, so these two terms will cancel each other out. And now the three remaining terms in my numerator, h cubed, 3h squared, and 3h, all have an h in it, so that value can be factored out. So here we're going to have the limit as h approaches 0. We're factoring out an h, so what's left over on the inside is going to be h squared plus 3h plus 3. And that's all over h. Now that we factored that h out, it can cancel with the h in our denominator. So those two cancel. And now when we evaluate this limit, by plugging in a 0 for h, I'm going to get 0 squared plus 3 times 0 plus 3, which will simplify down to simply 3. So the instantaneous rate of change at the point x sub 0 is equal to 3.